So these are pieces. Yep.
Will the 1B test just be on this? It doesn't have 1A on it, or does it?
That is a great question. So your 1A was basically just on transformations and graphical characteristics. Did we go over that stuff in 1B? Yeah, that's what we did last class. So yes, all of that, like, remember math things build upon themselves. So thinking about if you have kind of still, if you're still struggling a little bit with your graphical characteristics, that is going to still be on the test. But think about, what is this unit mostly about? Absolute values. So think about all your graphical characteristics and transformations are all going to be within what function? All within that absolute value function. So that's kind of how that would go. Alright, so we're doing piecewise today. So piecewise, we've looked at these graphs before in that 1A unit when we were talking about the graphical characteristics. It's stuff that looks like that Ireland graph on the wall over there. Things that are kind of broken up, kind of not like a continuous graph. So as you can see how they're broken up here, see how there's kind of two different pieces for that graph. So you're going to go like piece by piece with this. So here's our first piece. So just kind of as a there's kind of two different ways you can think about it. We'll go over problem one, thinking about it one way, and then we'll go over another problem, thinking about it a different way. So everybody thinks differently, so whatever kind of method you find working best for you is the method you can kind of work on your problems with. So this first way we're going to talk about is kind of just graphing it as a whole, and then kind of erasing the part that we don't need. So let's first think about that graph, f of x equals x plus 5. How would I graph that? Well, where would I start? What would you start, Luke?
So you'd start at 0, 5.
Yeah, your y-intercept of 5. And then your slope is what? Slope is 1. So think about, here I have a slope of 1 with a y-intercept of 5. But let's read what our restrictions are. I only want this graph when x is less than -2. So thinking, if I go to my graph here where x is -2, so think this dashed line that I'm lightly drawing right here. Also, if you have a pen, kind of wait. I should have said this first. Sorry, if you have pencil, you're fine because we're going to erase stuff. But if you have a pen, maybe wait till the end, or you can kind of just squiggle through it. So this right here, x is less than -2. So where is x less than -2? Is that everything to the left or everything to the right? To the left. So think about everything to the left here, I want to keep on my graph. And everything that's to the right, I don't want that anymore, so I'm going to erase it because I only want it where x is less than -2. Now let's think what's happening when x is less than -2. What should I have here? A dot. Should that dot be closed or should it be open? Open, right. We know it should be open because it says less than. Alright, so that was our first piece. So let's check out our second piece, which I'm going to draw in blue. So think about this is saying I have f of x equals -2x minus 1. So that's what I would graph. So if I was just graphing this in general, where would I start? What's my y-intercept? -1. And then my slope is what? -2. So I'm going down to right 1. Or up to left 1. So what happens right here when I get up to left 1 at this point right here?
We got a problem.
We got a problem. So I have, what type of circle should be here? Closed or open? A closed. So remember, closed circle is always trumping that open circle. So that closed circle is going to go over top of that open circle. And there is our graph. So now we're going to evaluate f at a few places. So I have f of 3. What does that mean? My x value I want to evaluate is what? What's our x value we're working with here? 3. So let's think. Should I be using the first piece or the second piece when I'm looking at f of 3? The second, because 3 is my x value, and that's greater than or equal to -2. So let's think how I would figure this out. My x is now 3, so I'm inputting 3. How is x 3? It told us in this problem right here. F of 3, remember that means your x is 3. Okay, good question. How do we know which problem to pick? I look at my x. My x here is 3. I have two options. Here, what does it say? X is less than -2. Let's see, does this work here? Is 3 less than -2? No. Here, my x is 3. Is 3 greater than or equal to -2? Yes, that's how I know I need to use the second one. So what's my output here? -7. So let's check out our next one. F of x -4, so our x is -4. Are we using the first or the second one? The first one. So -4 plus 5, what's our output? Alright, and then lastly, we have f of -2. Should we use the first or the second one? So who can raise their hand and tell us why should we use the second one here? Why should we use that one, Joe? Yeah, the -2 is included. How do you know it's included? That or equal to. So after we plug in -2, what's our output? Alright, does anybody have any questions about that first one? So we're going to jump around a little bit. You guys will do number 2 on your own. We're going to jump to question 4 on the next page. So question 4's got 3 pieces to it. So we'll still just go piece by piece. But remember this one I said? We're going to think about this one a little differently. Last time we thought about graphing it as a whole and then kind of erasing the part we didn't need. Now we're just going to kind of plug in points and then use the slope to go from there. So my first piece is -x plus 4 when x is less than or equal to 0. So kind of think I want 0 and everything to the left. So I'm going to get that point where it's right at 0, and then use my slope to kind of draw my line for everything to the left. So if my input is 0, so when my x is 0, what's the output? Just plugging in 0. So 0 plus 4, your output is? Yep, so at that point, 0, 4. What type of, should we have closed or open? Yep, a closed circle because it's the or equal to. So we had a -1 slope. So think about I could be going down and then to the right one. But do I want to graph things to the right? No, it says x is less than or equal to 0. I want to graph things to the left. So instead I'll just go up and then left, up and then left. That still gives me that -1 slope. So let's look at our second piece. We have y equals 2x minus 5. When 0 is less than x and less than or equal to 3. So thinking about our input, our first input could be 0 because that's our first starting value. So if your input is 0, what's your output here? -5. Remember, that makes sense. It's your y-intercept. So at -5, what type of circle should we have? Open or closed? Open, because it's a less than. And remember, you need 2 points in order to make a line, right? So your other input could be 30, so you can kind of go to the end. So think about if your input is 3, what is your output? Yeah, so I know I have the point 3, 1, and that's a closed or open circle. Close for the or equal to. So just double check if you were into graphing. Think about why this would make sense, right? Your slope is 2, so I'm going up, 1, 2, over 1, up. That's a good point. Up 1, 2, over 1, up 1, 2, over 1. So yep, that is my line with that slope of 2. So whatever way works best for you, you can use. And then our last piece is going to be f of x equals 2 when x is greater than 3. So how would you graph something that looks like y equals 2? What type of line is that? Yeah, it's a horizontal line. So it's a horizontal line when y is 2. And that is when x is greater than 3. So at 3, what type of circle will we have? Open circle. So let's look at the questions down below here. So we have f of negative 2. So let's think, should that be the first, second, or third piece here? The first. So my input is negative 2. What is my output? So my input is negative 2. So remember, it's a negative times a negative 2 plus 4, which would be 6. Now I'm going to input 0. So what does that mean? The first, second, or third one? It's going to be the first one because we have that 4 equal 2 with the first one. So my input is 0. What's my output? 4. What's another way you could figure this out? If you have your graph, you could just look at your graph, right? So see how you have your x is 0, your output is 4. But another thing, if you make a mistake on your graph, if you're actually plugging it in, you're gonna figure out your mistake if you're plugging it in. So that's another thing to keep in mind. If you're plugging it in, people in the last class were realizing that they were graphing incorrectly because of when they were plugging things in. So f of 5, what's our output when our x is 5? 2, right, so think about this last piece here. 5 is greater than 3. Your output is always going to be 2 in that scenario. Any questions on graphing so far? All right, we'll do one with an absolute value, and then we'll do 2 examples where we're just writing the equations, and then you guys will have some work time. So let's do number 6 together. So our first piece is y equals negative 4 when x is less than or equal to negative 3. So once again, what would that look like? A horizontal line at negative 4. And we should have what type of circle? Closed circle. I went 1, 2, 3 over. For my x is negative 3, and then I went down 1, 2, 3, 4. So next up we have the negative absolute value of x from when x is from negative 3 less than x less than or equal to 3. So once again, if I'm graphing the absolute value of x, what does that graph just look like? The V. But if it's negative, it's going to look like a upside down V. So think about, if you know that, you could graph that, or you can plug in your points, right? If I plugged in 0, my output is 0. If I plugged in negative 1, my output is negative 1. If I plugged in 1, my output is negative 1. I plugged in negative 2, my output is negative 2. I plugged in 2, my output is negative 2. and then so on. So at 3, we'll have that closed circle. What about at -3? We'll have what? An open circle. So once again, you can always use that idea of creating input and outputs to help you graph whatever you're working on. So let's evaluate. So let f of -4, what is that equal to? F of -4, what's that equal to? -4. What about f of 0, what is that equal to? 0. And f of 3 is? -3.
Do you do any shading with this? No.
So that's a good question. So look, even though we have inequalities, these inequalities here and here are your restrictions on where it's applicable to your x values. So you're not shading here, because think about what this is really saying. This is saying f of x, which is like y equals -4. That's one thing you're graphing. Your other thing you're graphing is y equals negative absolute value of x. These inequalities are just telling you where to graph it from. It's not telling you to shade or anything. That's when you have something like y is greater than x plus 3. When like your absolute value is like with your y, or sorry, inequality is with your y. Any other questions? So let's look at a few where we would be writing our equations. So flipping to this last page here. So we'll do 7 and then 9 together, and then you guys can try the other ones on your own. Alright, so when I'm explaining this, I'm going to kind of label each. Does everybody see how we kind of have 2 pieces here for piecewise? So let's just talk about piece 1, this part to the left. What is the equation for that line? Like y equals what? Yeah, y equals x. Your slope is 1. You go through your origin. Remember, if you ever need help creating your equation for your line, you can use your point slope formula in case you need help creating your equation. So let's think. That's when your x value is what? When your x value is what? Less than 0. So let's talk about it. Are we thinking about, do we use less than, or do we use less than or equal to right now? So let's talk back about the very first problem we did. So in this very first problem we did, we knew exactly like where we were going to have that closed circle because the problem told us. But let's say, for example, we weren't given this and we were just given our graph instead. Would we know which one had the closed circle? No, we wouldn't know which one had the closed circle. So when you have like the scenario where you have a closed circle, kind of where your pieces are coming together, your options are you can make one of them closed, the other one can be open, or you can make them both closed. So thinking about for this example, why it's okay if they're both closed, it's because if I was to input -2 in the first one in the red, what's your output? Your output is 3. What about when we input a -2 in the second one? Your output is 3. So it's okay if they're both the closed circle because their outputs are the same. Does that make sense? So it's okay if they're both the or equal to's because their outputs are the same, or you can just have one be or equal to. So we have options from here. We can keep this as less than, or we could keep it as a less than or equal to. So just note that you have those options. See how you don't have an option here in 8 though, because you don't, it's not like where they're overlapping. Alright, so let's look at our second piece. So our second piece, what's that equation for that line? Y equals, what was it, Joanne? 2x, thank you. So y equals 2x, and it's where x is what? Yes, I have to use a greater than or equal to here because it's a closed circle. If I didn't use it in the first one, then I have to use it in the second one, or I could have used it in both, or I could have, something about or, you could have had x is less than or equal to 0, 2x is greater than 0, or you could have even had x is less than or equal to 0, 2x is greater than or equal to 0. Remember, it's okay if they're both or equal to 0 because their outputs are the same. Those outputs there are both 0. Does everyone understand that? Alright, so let's look at 9 together and then you guys can try the rest of those on your own. So once again, looking at it piece by piece, so let's start with this first piece all the way to the left. So what's our equation for our line here? Y equals what? So if you aren't sure, remember you can use your point slope formula, or you can kind of keep going. What's your slope here? Your slope is what? 1. So if I keep going up 1 over 1, what do I find my y-intercept to be? 2. So my equation is x plus 2. And that was when x is what? Not greater than, but less than or equal to -1. So let's look at our second piece, the one in the middle. So what is our equation for our line here? X plus, try coming in 1, 2, 3. X plus 3, and it'll be from -1 is less than x, less than 1. Make sure you're writing that as that and statement there. And then your last piece, what's our equation for our line in the last piece? Yeah, so you have x plus 1, and it's when x is what? Greater than or equal to 1. Alright, so we have a good chunk of time. Super good chunk of time. So we got like 45 minutes is